All right, good afternoon, everybody. We want to thank you for your time being here, Professor Weiss, Professor Ramirez, and anybody watching the recording right now. My name is Ben Fisher. I'm the project manager for Fishy Consulting, and we're going to walk you through our progress on the Brook Subdivision project. So we're going to talk about what we've done so far, what we plan to do, and then some of the research we've done on our preliminary alternatives. In addition to project manager, I'm also the structures lead, and I will be providing the design of a 20,000 square foot senior design or senior living facility.
My name is Hunter Knackle. I will be designing stormwater best management practices for BMPs for both flood control and water quality.
Hi, I'm Dana Fish, and I'm the environmental lead for my team, and I'll be handling the wastewater collection system design and lift station design, as well as methods of bank stabilization.
I'm Andrew Vosberg. I am the transportation lead, and I will be designing the roads, the parking lot, and the walking paths.
All right, thank you, everybody. First up, I'm going to walk us through the budget. We have our rates and our hours up on the screen here. With all of that, the direct labor, overhead, and profit comes out to just under $75,000 after contingency, and the survey sub-consultant fee, our total is $88,300. Next up is our schedule update. I know this is a little hard to read right now, but each section will be gone into further in the respective disciplines. The dashed line is where we're at right now. The darker green color is work completed, and the lighter green is either in progress or planned work. So as you can see, we are on schedule right now and plan to keep it that way. So first up is our water resources.
Okay, I'm going to take you through some of the progress that I've made in relation to water resources. So starting off, we're going to define the scope a little bit. As presented, all local regulations should be followed. The client also requested 80% TSS for total suspended solids, as well as 50% of the total nitrogen load to be removed from the water. This will be accomplished using the design methods, which stands for low impact development. The client also would like for 1.25 inches of rainfall from all impervious areas to be treated as the water quality volume. And the figure on the right shows the scope area in red. It doesn't include the entire roadway portion because the design of that area would become quite redundant. So determining the water quality volume, I used these two equations, and as mentioned earlier, the client desired 1.25 inches of rainfall from impervious areas to be the water quality volume. However, the city of Valparaiso requires 1 inch of rainfall from the entire site to be used as the water quality volume. So both values were determined, and the higher of the two was chosen. Additionally, there are two different water quality volumes, one for the roadway and one for the building plot. This is because typically a developer will purchase a plot of land and design the roadway portion, while the client will purchase a plot of land from the developer and develop that plot of land. The values in the chart are increased with the factor safety of 15% due to uncertainty with alternatives of other disciplines. For flood control, the rational method was used. The highest storage volume using varying rainfall intensities for the 100-year design period was chosen for the flood control volume. The final flood control volume, though, is the water quality volume minus, or the flood control, the storage volume minus the water quality volume, because water quality BMPs will have filled up before flood control BMPs begin to take on the water. Again, it was increased by the factor of safety of 15%. So moving into alternatives, several have been listed here for both water quality and flood control. I have eliminated a few already, including underground detention and infiltration trenches, as these practices are more expensive and typically are only used in applications where there's not as much available space. The Brook subdivision plot has more than enough available space, so the less costly alternative will be used. A total of 4 combinations of water quality and flood control BMPs will be presented within the technical memo. So To date, I have completed 2 of 4, so I'll go through those. Alternative 1 uses bioswales to transport and remove solids from the runoff, while rain gardens with the saturation zone are used as the main source of nitrogen removal. Both the building plot and the roadway portion of the design use a dry pond as the flood control DMP. In the figure, the arrows show the direction in which water will flow based on the watershed delineation, existing contours, and potential excavation or earthwork. The second design is quite similar, as it uses bioswales and a rain garden again. The key difference being the wet pond. This design is a little bit different than that of the dry pond. Additionally, floating treatment wetlands are used within the flood control BMP as an additional source of nitrogen removal. Outlet arrows on the flood control plot. Flood control BMPs are showing both alternatives as a possible location where water may flow off the site at an allowable release rate of 0.5 cubic feet per second per acre of developed land. Continuing with future work, alternatives 3 and 4 will be developed further. I have decided on their water quality and flood control BMPs. I just haven't got the sizing and the location completed yet. After that, I will complete cost estimates of all 4 alternatives and use that in conjunction with other selected design criteria to evaluate the alternatives. And then finally, I will select the most desirable alternative for design beginning next semester. My schedule is updated, is shown there on the right. So now I'll turn it over to Dana with environmental.
Thank you, Hunter. So as I said before, I will be handling the environmental scope of the project. And as you can see here in this figure, this outlines the project limits of the environmental scope. So I will be designing a wastewater collection system that will, where a lift station will be pumping the wastewater to be treated at the wastewater treatment plant in Valparaiso, and also this is where the location of Greedy Creek is, where I will be designing some sort of stabilization method. The environmental scope will be in compliance with EPA and local guidelines. Some of the work that I've completed so far includes the preliminary calculations of peak factors for the maximum flow rate and the quantity of wastewater for the subdivision. I've also determined general alternatives for the pipe material of the wastewater collection system, as well as lift station location and bank stabilization methods. So the collection system design will be a gravity flow sanitary sewer system that will be comprised of several sanitary manholes. The gravity flow sanitary system will carry the load of a two-story senior living facility that will be designed by our structural engineer, 175 homes, and a closed swimming pool. And as you can see from the figure on the screen, I've also determined the high and low points of the subdivision, being the high point on the west side of the subdivision and decreasing in elevation moving east. And as you can see, I've also chosen the desired alternative materials that could be potentially used for the design of the collection system. And they will be following the standards according to the American National Standard Institute. So the collection system design will be following the alignment that will be proposed. It will be following the alignment of the proposed roadway designed by our transportation engineer, and it will be dependent upon the location analysis of the lift station. And as you can see, this is the south pipe network layout of the transportation alternative 1. Some of the future work for the design of the collection system entails the evaluation of the pipe material alternatives, as well as sanitary manhole design and performing a comprehensive cost estimation for each alternative. So I've also determined that each lift station will be a submersible lift station as opposed to a dry well station due to its cost effectiveness and the lack of above ground structure, which I believe will be more aesthetically pleasing and more enhance the visual appearance and blend well with the residential environment. And on this slide, you can see that this is the west pipe network layout for the transportation alternative 1, and this is the north pipe network. I have concluded that the north and west pipe networks may not be the most viable option due to how close they are to Beauty Creek, which would require a necessary pipe casing, which would drive up the cost. And this pipe casing is used to prevent the leakage of potential contamination of the groundwater, and keeping Beauty Creek wildlife from harm as well. So in order to transport the wastewater from the subdivision to the wastewater treatment plant, a force main is necessary, and this is one of two options that I have included, and it will be dependent on the lift station location analysis. This green pathway, as you see here, is the 5,100 meters in length, and this one is 4,844 meters in length. And as you can see, it will follow major roads such as Froberg Road and State Road 130. Future work in the design of the lift station includes selecting the pumps and determining the number of pumps that will be needed, which will be dependent on the pipe material analysis of the collection system. I will also be continuing the design of the force main sewer and ultimately coming up with alternative evaluations and a comprehensive cost analysis. And the last part of the environmental scope is the bank stabilization methods. The first alternative is the green locks vegetated slope facing system, otherwise known as BSF. This is courtesy of the Filtering Sustainable Technologies. Some of the major components include a green sock, geogrids, soil anchors or by staking, vegetation, and in some cases a limestone base. So a green sock is a trademark product of Filtering Sustainable Technologies that is a mesh that contains growing media. This option is viable in my opinion due to its aesthetic properties and keeping the residential visual appearance at a max. The second alternative will be a bank, crib, and cover log hard engineering practice. It is a method that will that is designed for erosion control. It involves abutment work, installation of 6 to 9 meter length crib logs, as well as rebar that will, as you can see here, keep the cover log and crib log together. This is a practice that is beneficial in protecting the toe zone of the bank from undercutting and flanking, and it provides good overhead cover for wildlife and fish, and can be placed in any area of the bank that is unstable. My future work in the bank stabilization is determining a third alternative, as well as evaluating all three comprehensively and coming up with the cost estimation for each. And lastly, this is my schedule that shows the work that I've completed so far and the work that I will continue to be working on in the future. As you can see, we are kind of so up to date and on time. And with that, thank you for your time. I will be transitioning over to our transportation engineer, Andrew.
Thank you very much. First, I'll be going over the scope. Now, I'm tasked with designing 2 roads. One will be connecting the 2 discontinued ends of Ville Park Road, and then extending Old Oak Drive to meet that new road and create a T intersection. Now, I've been told that the intersection will be a stop control with Old Oak stopping for Ville Park. Because there are no alternatives, it will not be discussed in the presentation. I will then move on to designing a senior living facility parking lot, and then a walking trail that will be on the north end of Ville Park Road, and then it will meet the existing trail at the intersection. here's my design criteria. Everything will be designed in compliance with the ASTRO Green Book, the NDOT Design Manual. You have the City of Valparaiso ordinances, and then the Americans with Disabilities Act. My first set of alternatives is for the parking lot. Both are 179 feet by 124, and I'm required to have 42 standard spaces, which are 9 by 20 feet, 2 disabled spots, and then 1 van loading spot. Now on the left, you have your typical 90-degree parking. It's very easy, everybody knows how it goes. But you have elderly people driving, it's easy for them. On the right side, you got 30-degree parking. It's got a nice flow to it, one-way travel, but elderly people, they might not know, okay? You're gonna need a lot of signs, a lot of marks in the roadway, so they know where to go. And then you can see I got dumpster access in the top right corners of both alternatives. Next is the roadway alignment alternatives. See on the left hand, the first Ville Park will go under the building, which is easy, it follows the trail, aesthetically pleasing as you're going in front of the building. And on the right side, the Ville Park Road will go behind the building, and then the building will be set in the intersection. That way you have 2 points of access into the parking lot, just more freedom of travel, but it will be behind the building, less aesthetically pleasing to look at the back of a building. And then you can see the walking trail on both at the top, and then connecting with the existing at the intersection. Lastly is my cross-section alternatives. Now both of these are a little typical section of Ville Park Drive Road. And the first alternative is your basic road. Okay, everything set to the desirable numbers from the NDOT Design Manual. You got your 2 12-foot lanes, you got a 12-foot lane in the middle that was required to have turning from both directions. And then on the right, I added a parking lane, because you know we are in a neighborhood. People like easy parking, especially if parties, get-togethers, you name it. And then Old Oak will also have a parking lane alternative. Lastly is my future work. I will be selecting an alternative based on cost, aesthetics, you got practicality, and then safety. And then I will take everything together and make a cost evaluation. And on the right, you got my schedule, up to date on everything, and then everything I've left is what I just stated in the future work. Now, let's bring it back to my PM. There you go.
Thank you, Andrew. As mentioned, the scope of the structural work is going to be a 2-story, 20,000 square foot senior living facility. This will be designed to the Valparaiso set of standards, and they have adopted the 2014 Indiana Building Code, as well as the American Society of Civil Engineers 722 manual. So the building itself will have 27 residential units. The location was chosen in coordination with each of the other teams. It is at a local elevation high point, which optimizes the design for both stormwater and wastewater, and it is right near the proposed intersection, which will aid in traffic. Some assumptions we made in the process of those designs were that there would be 30 units in the building, which is a little bit conservative, a 1-to-8 care staff to resident ratio, and 10 to 20 additional either non-care staff or visitors in the center at any given time. And the results from those were included in the respective sections. So as far as floor plans, these are subject to change pending the beam and column design for each alternative, but this should be fairly accurate to what it's going to end up being. The first floor has 10 residential units, public dining room space, kitchen, lobby, front desk, and some offices. The second floor is nearly entirely residential with the same stair and elevator locations, as well as a small lounge. As you may have noticed, there is a horizontal irregularity in the structure, which can be important or can lead to structural instability in seismic loading events. Using the ASCE hazard tool, I determined the structure to be in seismic design category B, which is only subject to equivalent lateral force analysis, which requires no additional work. So moving on to the loading, the dead loads will be dependent on the material I use. Live loads were obtained from the ASE manual, as well as snow and wind modes, which are all displayed in the table on the right side of the screen. Also, I determined the structure to be in risk category 3, as it is a senior living facility, and there will be people in there constantly. The alternatives I plan to investigate are a reinforced concrete structure, a structural steel structure, and a timber structure. Something I didn't get to show earlier is its exact location on the site. I'm sort of blown up for you in the top right corner. Within the project limits, right near the proposed roadway, and you can also see the parking lot estimated area in blue there. Alright, so for my future work, I'm going to perform a preliminary design of each alternative, including beam and column layout, constructability considerations, as well as cost. Going to then evaluate and select the most desirable alternative, and then between now and then there will be some meetings and reports and a presentation. With that, I'd like to thank everybody for their time and open it up to any questions. Yes.
Okay, very nice presentation. Oh, wow, you are covering a lot of topics. I don't know if this question is for which one of you, but I'm going to open it to everybody. The question is, now that we are with this global problem about climate change, and everybody's thinking about, hey, we need to start implementing what is called the alternative energies. I am wondering if in your structural part you are considering installing solar panels, yes, or having another, there is something that is called the flower from that opens when there is sol and then covers, and the footprint is very small. That's another alternative.
I think electricity generation would be up to the client and developer, but I could surely include into my design enough capacity to handle anything they want to add.
The idea is the extra weight, yes, the extra weight there.
Yeah.
The second part is, there is something that is called, especially that this is a kind of residential, yes, right? There is something that is called the LEED, Leadership in Energy and Environmental Design. And of course, this is the direction that all the civil engineers, especially this kind of project, need to move, yes. And that's one of the 14 challenges for all the engineers, according to the National Academy of Engineering of the United States. They say, hey, infrastructure, we need to make it more friendly for the environment. Are you including anything about leadership in environmental and energy design?
Currently, to my knowledge, we are not. I think a lot of those principles could be very helpful in our design, but it was not a priority listed by a client in the scope of our work. Any other questions?